Our binary number is going to have 8 ones and k additional zeros to give us 8 plus k digits. Let's see if we can figure out how many digits are in the 1000th number in this sequence. Our first number will have just 8 digits, and all of the digits are 1. If it has at most 9 digits, that's going to be 9 different binary numbers. If at most it has 10 digits, that's 45 different numbers. If the maximum is 11 digits, it'll be the 106th number in our sequence. With 12 digits, that's 495 numbers. And at 13 digits, we have over 1,000 numbers. This means that the 1000th number is 13 digits. So k equals 5 zeros in binary. Our 495th number is 12 digits consisting of 8 ones followed by 4 zeros in base 2. This is the largest 12-digit number that satisfies the requirements for having 8 ones. The 496th number in our sequence will be a 13-digit number with a 1 out here, 5 zeros that follow, and then 7 more ones. This is the smallest 13-digit number that satisfies the problem statement. So our number n, the 1000th number, is going to be in this interval. A 1 with a 5 zeros and 7 ones in base 2, and then the largest can be is a 1 followed by 7 ones. In our sequence, this is the 496th number, and this is 1287. The 13-digit numbers that begin with a 1 can be divided into 2 categories. They can be numbers that start with a 1 and a 0, and then 11 digits after that, or a 1 and a 1 with 11 digits. From these remaining 11 digits, we pick 7 of them to be 1s and the remaining to be 0s. That's 330 different numbers. Over here, again, we have 11 digits to fill in, and 6 of them can be 1s, which is 462. We'll start with the largest 12-digit number, number 495, and then we'll add these 330 numbers to get 825. Our 825th number starts with a 1 and a 0, and then we put the remaining 7 ones first, and then the last 4 zeros after that. Our 826th number begins with a 1 and a 1, 5 zeros after that, and 6 ones in base 2. So far, this is our new lower bound. Let's see what happens if after our 825 numbers that begin in 1, 0, we add in these 462 that begin with 1 and 1. This is 1287. That's the same answer that we got before, but it's also too high. So let's revise our bounds on n. This is our 826th number, begins with a 1, 1, 5 zeros, and 6 ones, and it ends with the largest 13-digit number that begins with a 1, 1. That means we put our 6 ones here, followed by the 5 zeros. This is number 1287 in the sequence. These numbers can be divided into 2 categories. We have numbers that begin with a 1, and a 0, followed by 10 additional digits, or a 1, and a 1 with 10 additional digits. Filling in the rest of these digits, out of 10 of them, we have 6 more ones. That's 210 more numbers. For these, we just have 5 more ones, or 252. We'll start with the number that comes before 826, 825, and we'll add 210. This gives us 1035 and the new upper bound for n, so we actually don't need to worry about these numbers. And again, our 1035th number begins with 110, and then we're going to follow that with our 6 remaining ones and our 4 remaining zeros. Let's rewrite our bounds on n again. This is the same as our 826th number, and this is our new upper bound, our 1035th number. 13-digit numbers that begin in 110 can be divided into 2 categories. Numbers that begin in 1100 and then 9 remaining digits, or numbers that begin in 1101 and 9 more digits. From these 9 digits, we pick 6 of them to be 1s. There are 84 ways to do that. Here we have 5 ones. Since 826 is in this category, we'll start with 825, and we'll add 84 to get a sum that's less than 1,000. So this is our new lower bound on n. Let's see what happens when we add these remaining numbers. We start with 909 and add 126. This is 1035, as expected, so still too big. Let's check again. Our 909th number begins with 1100, and then we maximize the rest of the digits, putting the 6 ones first and the 3 zeros last. The number that follows begins with 1101. We have 4 zeros here, and then 5 ones after that. Our 1035th number, again, begins 1101, 5 ones, and 4 zeros. And we'll rewrite the bounds on n between the 910th number and number 1035. We'll divide these up again into numbers that begin with 11010 and 8 remaining digits and 11011. From these 8 remaining digits, we choose 5 of them to be ones. There are 56 ways. And here we have 4 ones, and there are 70 ways. We'll begin with the 909th number because the 910th one falls into this category. So we'll start with 909, add 56, and now we're up to number 965. This is our new lower bound. And we already know that when we add on these 70 additional numbers, we'll get 1035, as we saw before. So again, our 965th number begins with 11010, and then we put all 5 of the remaining ones here, followed by 3 more zeros. And the 966th number bumps up a 1, replacing it with 4 zeros and 4 ones. And now we'll rewrite our bounds on n again from the 966th number to 1035th, and we'll divide these numbers into 2 categories. Numbers that begin with 110, 110, and 7 more digits, or numbers that begin with 110, 111. Out of these 7 digits, we have 4 more ones for 35 ways. Here again, we have 7 digits. We've used up 5 ones, that leaves 3, also 35 ways. The 966th digit falls into this category, so we'll start with 965 and we'll add 35. Happily, this adds up to 1,000. So the largest number in this category that begins with 110, 110, and then we put 4 more ones, and then our 3 remaining zeros. This is our 1000th number, or n. Let's write these as powers of 2. It's a 13-digit number, so our first one is 2 to the 12th power, followed by 2 to the 11th, 2 to the 9 and 8, and then these remaining 4 powers of 2, 6, 5, 4, and 3. With these higher powers of 2, I'll go ahead and write them in terms of their mod 1000 residual. This is 48 and 96. So I'll make that substitution here. In mod 1000, our answer is 32. If you'd like me to solve any other math contest problems, please leave them in the comments.